Hello everyone and welcome back. This is lesson 2 covering variables in Java, or object-oriented programming really. If you made it this far, congratulations, you made it past the hardest part. Yesterday's lessons, or the last lesson, was probably the most boring and most difficult. Just a quick overview on hardware and software, not the most exciting stuff, but today I promise you we're going to do at least a little bit of programming. In this lesson, we're going to talk about variables, but we're also going to get our first touch into our first experience with some programming, some syntax, which is the grammar of Java or programming languages, and we're also going to do a tiny bit of setup because this is the first time we're opening up BlueJ. So without further ado, let's kind of just go ahead. So whenever we look at a variable, just like in math, a variable is just a container that holds a value, right? So if I were on my computer and this is the memory, right? Our RAM, I guess. I don't like calling it RAM, just call it memory. And I create a variable. That variable is just an empty container. Inside of it can be anything. It can be the number 3, it can be 3.14, it could be something. The container itself is the variable. The number inside of it is the literal, right? So the number 5 is a literal. The number 6.9 times 10 to the 6th is a literal. But the variable, like x and y in math, is going to be just the container that holds it. There are two types of variables in object-oriented programming. There are primitive type variables and reference type variables. In some more modern languages, I think in Python, for example, I'm not entirely sure of this, but I believe in Python, all variables are reference type variables. But in C, C++, C#, and Java, we have primitive type and reference type variables. But what's the difference? A primitive type is what you see here. It is simply just a container, and inside of it's going to be a number. And the number is the value of the variable. A reference type variable, such as a string, strings are going to be the only reference type variables we kind of use today. Strings are really big. We're about to see that a variable has a limited size. In fact, it's the size of your CPU maximally. So if your CPU is 32 bits, that's as big as this can get. It can get smaller. There are a few variables that are smaller than 32 bits, but that is the biggest your CPU could handle. But what if I have something like an entire sentence, right? You can imagine that an entire sentence be made up of so many pieces of information that it's too big to fit inside of a single container. So what we do is we write it out something like hello, somewhere else in memory, right? Some number, let's say this is the reference number to the memory location. That's what the pound sign means. And what we're going to store here is that memory location. So it's still going to be a number. I just don't have any numbers off the top of my head. This is called a pointer. This will point, hence the name, to the memory location where the variable, in this case the string, is actually stored. So that's what a reference type variable is. It references another location in memory. But at least this location in memory is where we start. So that's what's held inside of the container when we create that variable. The variable will actually hold a reference to another location in memory. Sounds a bit weird, but we have to tell the computer to start somewhere, and this is where it starts when it talks about reference type variables. So what are the different type of primitive type variables? Here's a list, here's the size, here's the minimum and maximum, and let me just kind of go over this a little bit fast. First, we have bytes, which we are familiar with. It's 8 bits. Minimum number is -128. Maximum is 127. The reason I highlighted char is to point something out here. Char is a character. So A, B, C, D, left to right parentheses, exclamation mark, question mark, apostrophe, anything. These characters are only really useful to us humans. But the computer needs to eventually convert it down to binary, right? So first we're going to convert it from a character to a integer, and then the integer is easy to convert to binary. So when we specify that a variable is going to be a char, it's going to be one and only one character. That character will have up to 16 bits to store, and the minimum will be 0 and 65. The maximum is 65,565. Obviously, as I said in the last lesson, this is an unsigned bit. All of the other integer types are signed bits. Right? So short is a 16-bit integer. Int is integer, and it's the most commonly used version of integer. It's 32 bits. Here's the most negative number. Here's the most positive number. Right? So long is just a really, really long version of it. It's massive. Float and double are a little bit different. They're not integers. So if you notice, the minimum number is 1.4 times 10 to the negative 45th. That's still a positive number because there's no negative in front. It's still a positive number. So when we talk about float and double, what we mean is the smallest number we can get. Not the most negative, but the smallest number we can get, the most tiny. And the most maximum positive number we can get is 3.4 times 10 to the 38th. These numbers are still attainable in the negative direction, because remember last time we said that the leftmost bit, the most significant bit, is the signed bit always. So these numbers can still reach negative in the exact same range. Double is the same thing, except it's twice the precision. It's 64 bits, and double is actually the more commonly used, most commonly used floating point number. It's called a double because it's a double floating point number, and it has twice as many bits. So it has double the precision. I mean, obviously it goes a lot further than twice as big or small, but it has twice as many bits, double the precision, etc. All right, Boolean. Boolean is a variable type that can only hold two numbers or two values, true or false. Now, as it says here, this is Java Virtual Machine dependent. So how big it is depends on the virtual machine. But the only two values it can hold is true and false. Void is weird. The size is null. So 0 is still a number, but null is saying that it's not even a number, right? 0 still counts as a number, but null says no number at all. Think about reference type variables. If this value was a 0, 0 is still a location in memory. If I replace it, it's still going to point somewhere. Null is saying, if I replace this with null, so let's replace this with null. I can't write on the screen. I hate it. Null says there's no pointer at all. So no pointer at all. That's the difference. 0 will still point to somewhere, null will point to nowhere. In the example here of pointers, but in other examples, null is just null. It means no numbers at all. Okay, we're gonna come back to this actually. I'll explain this as I kind of go along, but let's go ahead and define a variable once in Java. So let's go to our desktop and open up BlueJ. When you open up BlueJ for the first time, you'll see something like this. Okay, first we need to make a new project. And actually I have some instructions here, so let me kind of skip around here. Create a new project called Day 2 Training. Day 2 Training. Sweet. Create a new class called Variable Examples. You don't need to know what a class is, but you do have to have a class. So just do this, but if you don't understand what's going on yet, it's fine. We will eventually get to it. Variable Example. See, now you have this little thing right here. This is your class. Double click on that. Okay, and now you have your class. I want you to delete all this up here. Then, do you see these curly brackets? See how it highlighted the last one when I clicked right next to the first one? I want you to delete everything in between those two. So it should look just like this. Public class variable, and so on. You don't need to know what's going on yet. The next thing I want you to do is just type this out. Public static void main, nope, string, left and right square brackets, args, close the parentheses, and then open and close curly brackets, Then I want you to put the cursor right there and then stop. Okay. This is called creating the main method. We don't know what methods are yet, but you have to have this. This is the starting point of every program. This is where the program is going to start no matter what, and it's going to go line by line, one at a time throughout your entire program. We have 0 lines of code in here, so it's not going to do anything. It'll run, but it'll do nothing and then stop. You don't need to know this, but I do want you to memorize this. Public, static, void, main. Left parentheses, string, left and right, square brackets, and args. You can move the square brackets after args, but just for the sake of simplicity and uniformity between all of us, let's just keep it here. We're going to declare each of the primitive type variables, but let's start with one. In order to create a variable, you have to do 3 things. Well, to declare a variable, you only have to do 2 things. First, you have to declare the type of variable it is. So for us, let's just choose integer since that's the easiest, int. Next, you have to create a variable name, right? It doesn't really matter what you call it as long as it's a single word. But it doesn't have to be only just like the word head or tail or left or right. It can be multiple words as long as there's no space in between them. So I can say int num of students, right? So what I did was called camel case. Num, notice that the O in of is capitalized and then S in students is capitalized. I capitalized the first letter of every word in my variable, but it's all one word, right? That is the key thing. That is a necessity. That is required. I don't care what language you're using, it has to be one word. Some languages will instead use snake case, which looks like this, right? Where you use an underscore to separate space. Some say that this is more easy to read. Some say that this is not as easy to read. Or some people use snake case in some cases. In some cases, they use camel case. This is what this is called, by the way, because of the way that it has humps on it like a camel. So it's called camel case, right? To define a variable, that's it. So, oops. In Java, essentially what we've done is in the memory, when this line of code executes, we create a box and it's empty. I believe Java actually puts the number 0 here by default, but as far as we're concerned, it's an empty box. Now we can just leave it there. What we have here is called a statement. We have defined a variable. That's all we have to do. We can either stop there and we can add a semicolon. The semicolon is like a period in a sentence, right? At the end of any statement, which we're gonna get experience doing all kinds of statements, we have to have a semicolon. So let's say that that's it. That's all I want to do. Now this program doesn't do anything, but that's all I have to do to define a variable. If I want to store something into the variable, like put a number in there, I have to do, there's 2 ways to do this. I can either do this on the same line and do equals 5, and that's perfectly fine. Or I can define the variable and maybe later on down the road, I want to store it later. So I can do num of students equals 5. So this is one line that defines a variable. On this second line, we are assigning a variable, assigning a value to the variable. Note that the variable is on the left and the literal, the value we're storing into it, is on the right of the equal sign. And then once again, we have to end the statement with a semicolon. Java, for the most part, doesn't care about white space, so this, should technically be fine. Notice that Java is not complaining. Now, if I did something like equals 1.1, right? I'm trying to store a floating point variable inside of an integer, Java will complain. If you see red lines like this is an error. If you hover your mouse, incompatible types, possible lossy conversion. I will talk about that in a minute. But for now, let's just leave it at a 5, and that's pretty much it. So we have to remember a couple things. You have to first, when defining a variable, when creating a new variable, you have to first define the variable type, then give it a name. Then either after it or on another line, you have to assign a value to it. Okay? That should be it for the most basic parts. But let's talk about some of the other languages here. So let's compare this to other languages. In Java, Java is called a strictly typed language. This is what they mean by strictly typed. I have to put the type of variable it is first. There are other programming languages where you can use the word var. Var says that this is going to be a variable. I don't know if it's going to be an integer, a double, a reference type, something else, a string, something. In other languages, you can do this. I know that Python can do this. I know GDScript, which is what we're going to use when we get to the programming, the game development portion of this, that's what we're going to use. We can use var as a random variable type, but it has no definition yet. That's a little weird, but Java explicitly says you have to tell me what type of variable it is. And part of the reason is because of this chart, right? Java knows and has a definition of the size of every single variable type. So if you say that this is going to be a byte, it knows to only reserve 8 bits for it. In Python, you don't have to define it, but it's going to make it as big as possible. So which one's better? It doesn't really matter. For the most part, just make sure that you get the right type. You have to explicitly say it. The other reason I bring this up is because you cannot take a larger size and put it into a smaller container. So this is an int, right? But if I say long, so if I create a number that's long, so let's say I say long global population, global pop equals. Oops, I don't need the 1, 2, 3, 4. Whatever it is, right? Hopefully that fits. Is that too big? Integer number too large. Okay. Let's cut it down by a few zeros here. There you go, that fits. So this is a number that's fitting long. Let's see what happens when I try to put that variable, global pop, into this integer. If I hover my mouse over, it says incompatible types, possible lossy conversion from long to int. Long is 64 bits, and we're trying to store it into something that's 32 bits. Java is warning you that it's not going to allow you to do it. It says, you know what? This is too big. If you do this, we have to cut some bits off. In fact, we're going to have to cut half of the bits off. I'm not going to let you do that because that's a loss of precision, and that can screw up a lot of programs. So you cannot go from a larger data type to a smaller data type. All right. If you guys want to stop there, feel free to stop this video here, but these are the core basics of how defining and using variables are. From here on out, for the rest of this video, is going to be a little bit extra knowledge so we get a little bit better in-depth understanding of how variables work. And I'm going to take the time to define one of every variable. So if I want to create a variable, let's say a float, and I do float pi, let's say 3.14. You'll notice that it complains because it says possible lossy conversion from double to float. When it comes to decimals, by default, to minimize the amount of precision loss, Java will automatically make this a float. A double precision floating point variable. But pi is a float, which is half the size of a double. Again, we have lossy conversion. There's two things we can either do. We can either change this to be a double, or if we really just only care about this, you can just put the character f at the end of it, and this will tell Java that this number is a floating point variable. And now it's not complaining. I've specifically told it it's going to be a float. It's storing it in a float. Everything's happy. Everything's good. Good to go. Whenever you use a number, by default, if it's an integer, it will default to int. I don't know why it doesn't default to long. I think it has something to do with, actually, to tell you the truth, I'm not sure. But if you make a decimal point, it'll default its value to double, which is what we just saw when we tried to store a decimal point into a float. Let's see, any other kind of trick there? Short, ints, long? No, I think so. I think we're good. So let's do the next one. Let's create a Boolean value. Boolean is short. Oops. There are two values a Boolean can hold. True, I literally just type out true, and that's it. Or false. That's it. And then semicolon to end the statement saying that this is the end. I'm done telling you what to do for this line. Let's move on to the next thing. All right, but that's what the Boolean is for. Booleans are useful for a lot of things. It's a lot of process control, like telling a program or a game, does character have key? Has key equals false. Okay, then don't open the door. Has key equals true, then allow him to open the door. It could be that simple. But what we're going to see it is eventually we're going to do a lot of comparisons. We're going to do comparisons in logic, right? Right now, all we're doing is just making empty ass variables in memory, and that's it. This is almost the most useless stuff in the world. But Boolean is going to be used a lot in Boolean logic, which we're going to cover later. Okay, I already talked about this. You have to first declare it, give it a name. Here's some syntax examples, and then you have to end with a semicolon. You can assign later or on the same line. How to name variables, camel case, right? Here's num of students. I use num of students over here. First character of every word, but it's all mashed together into one word because you cannot have any space in between. If I say has key and then put a space, Java's going to complain. Okay. Keywords. You may have noticed, let's skip the final portion of this. You may have noticed that some of these words change colors. These colors are called keywords. When Java changes the colors, it means that it's a keyword, which means two things. One, it means that it's reserved for Java's use and you cannot use it for something else. You cannot have an integer value called int, but you can have an integer value called integer. That's fine, as long as it doesn't exactly match int all lowercase. Right? Here's the color coding. If it's light red, it's a variable, or technically void is a variable type. If it's blue, it's a Boolean value. Notice that this is blue. Green is a string, so here, let's make a string real quick. String, my name. I have to do, this is how you define a string, Ben. That's my name, Ben. And then I have to end the statement. Don't forget to end the statement. That's something a lot of beginners forget. But that's it. So you'll notice that it turns green. All right. Purple is an access modifier to be explained later. Java ignores whitespace, sort of, which I just showed you. It won't ignore this whitespace. This whitespace is important, but I can put this on the next line and it doesn't care. As long as it keeps reading to the next thing and then as long as it makes sense to the semicolon, it all works. That's something you're going to want to get used to. You're just going to have to practice it. But for the most part, just kind of stick to my structure and you should be fine. There is one more keyword here that I want to talk about that you've already seen. And that's the word final. If I put the word final lowercase, it turns a dark purple or a maroon. And watch what happens when I try to change pi. I do pi, equals 3.141. It throws an error. Look at this. Incompatible types. Wait, and then I took F. I need to put the F there. Cannot assign a variable to a final variable pi. So what the word final means is I'm gonna give it a value, and that's it. You're not gonna be allowed to change it. This is really good for making constants. Now, if you ever make a constant, in other words, you say that it's final, the standard convention is to make the entire variable capitalized. This can get a little confusing, but this is just standard. If you do have multiple words, this might be a good time to use some snake case. So pi to places. That's a terrible variable name, but this is an example of one way to make it easier to read final variables. In other words, constants. So that's a really good way of preventing yourself from accidentally changing a variable that you don't want to change, because pi doesn't change, right? In math and science and reality, whatever. So you can do like final double acceleration and then put the Earth's gravitational acceleration rate, right? 9.8. But that's basically it. Be careful when mixing and matching variable types in arithmetic or storage. Yes, almost something I forgot to do. Let's do a little bit of arithmetic so we can get an idea of what's happening. If you mix and match variables, so dividing an integer by an integer always yields an integer. Whenever Java does some arithmetic like this, it's always going to just stick to whatever variable type, the biggest variable type you give it. So 5 is an integer, 3 is an integer. It's not looking at the division. It's just going, this is an integer, this is an integer. Well, I'm just going to keep everything integer. And what you'll end up getting is the number 1. You will not get 1.66666 repeating. If you give it an integer, it stays an integer. Keep that in mind because it'll equal 1 and not this. Trying to store a double in a float will cause an error. I already showed you that. You cannot put a larger variable inside a smaller container. That's what this is looking at. If you want to see this in action, do the following. First, we're going to have to do this, import java.util.star. Yeah, just do here. I'll just do scanner. Java.util.scanner. And then what I want you to do is just do the following: is scanner in equals new scanner system.in. For now, I want you to memorize this line. For those of you who are curious, I'm creating an object called in. This is just a variable name. It's just a variable name. It's not actually, it's significant to us, but not the computer. What it is this line creates the actual object inside the random place in memory, and then this is storing the reference to this thing. What this thing requires is some sort of input. It's saying, hey, I'm going to create something that reads input. Where am I reading? Because it could be a mouse, it could be a keyboard. System.in is just saying, just read the system's default input. You don't need to go into that right now. Just for now, just please just memorize this line of code. Next, I want to, let's see. I want to do system.out.println or ln, print ln. Memorize that too. And then I just want you to do 5 divided by 3. Now we're not using this line of code yet, but we will come back to it and I will use it in a minute. 5 divided by 3. What this line of code is, it says, in the system, go to the output. I want you to print something and then go to the next line because there's print and then there's print line. The difference is without the ln, you see this thing that's blinking? This is called the carriage. The carriage will print and then stay on this line. Print line, so that's what this will do. Print line will print and then the carriage will go to the next line. I like using print line a lot more. So how do we run this, right? Let's compile it and then go back to here. I want you to right click and just do void main string args. We're telling it to start the program. And if I open this up, you'll see the number 1. That's this line of code right here. Yeah, it creates an integer called num of students. It creates a final floating point variable called pi, and it sets it to 3.14. But we don't actually do anything with this. The only thing we do is divide 5 divided by 3 and output it. Now, if I do something like 3.0, this is different because now I've done some arithmetic, but the largest thing I used was a double. This is not a float, this is a double. So let's see how this changes things. Compile. Actually, I want to clear this out. Go to options and then clear. Right click and then tell it to run again. 1.66666667. All right, this looks more familiar. Be careful when mixing and matching data types. That's the key thing to understand here. Okay, so you can save this if you want. I want to delete it because I think that this is starting to get a little messy and a little hard to see. So let's make a brand new thing here, and let's start it with this line of code. Okay. We're going to take some input from a user, store it into two variables, and then output it. And I just want to save this here so I don't have to retype it. So let's do in.nextInt. Oh, actually, sorry. Let's create a variable called number1 int number int first number or first num, I don't care, equals next int second num. Actually, I like that. I like num a little bit better. Equals in.nextInt. Now this function tells the in, the thing that's scanning our inputs, to look for the next integer. So if I type a character out, it's gonna ignore it. It's gonna keep waiting until you give it an integer. Then when I give it an integer, it'll store it into first num. Then it goes to the next line and waits for the next integer. When you give it another integer, it'll store it into the second num. Then what I want to do is do first star second. Oops. First num star second num. So it's going to do the first number times the second number. All right, let's compile and run this. Actually, let's start here, and I just want to clear this out. And then, crap, wrong one. All right, it's waiting, so nothing's printing because it's waiting for us. Notice that we can type down here though. Let's just give it an integer to not break this. Okay, so 9. Give it another number 9. We should get 81. There you go, 81. Because Java, no, where is it? Yeah. We set 9 into first num. Then it stopped here, waited for the second number and assigned it to second num. Then the third line was to just print it out. That's it. So I'm going to leave it here. I'm going to stop here, and I want you to kind of just to review the things that we kind of went over. Oh, I could go over unary operations actually real quick. Let's see what else we have. We already did some simple math, comments, final notes. Okay, let's kind of review a few things before I talk about the operator. Don't forget that Java is a literal, no, what is the phrase I'm looking for? Strictly typed language. Means you have to first define the variable type and then give it a name. Then you can either define or set a value next or do that on another line. Personally, I like to assign it at least a default value, but you don't have to. The next thing is that I want you to just memorize is this line of code, this line of code with the first and the open and close curly brackets, and then in between it, I want you to memorize this line of code, the whole thing, including the S, and then this line of code. If you want to tell the user to input something on a command or from the keyboard, you need this line of code. So this is to output. What's in between here is what gets output. So even if it's just like hello world, I hate hello world programs. Even if it's as simple as hello world. Oh, I forgot we actually are still, okay, hello world. We still were telling it to wait for input, but we just didn't do anything with it anymore. This will output. You need this object in order to accept inputs, and then this is the command to do something with that input to take the next integer. You could also do next, which will just take whatever it is, convert it to an integer in this case, and then store it, but let's not get too complicated. Let's just use int. This line of code is necessary to start the program. And this line is necessary in order to use this, in order to do this. All right, but let's move on a little bit here. Let's talk about operators. We already know how to do addition, subtraction, multiplication, division. The modulus over here is the only one that's kind of new. The modulus is the remainder of the quotient. So in other words, remember how we did 5 divided by 3? 5 divided by 3 is 1 remainder 2. If you do 5 divided by 3, it returns 1. If I do 5 modulus 3, that returns 2. 5 mod 2. Compile. Run. We still have to do the inputs. 9, 9, 1. Oops, I divided by 3. Because 5 divided by 2 is actually 2 remainder 1. That's why we got a 1. That was supposed to be a 3. My mistake. And then I'll just do, so 2. Because 5 divided by 3 is 1 remainder 2. That's how the modulus works. This is actually really good for counting. So if you want to make sure a process goes around in a circle 10 times, you can just use the modulus, the like mod 10. So it'll go from 0 to 9. So if you have the number 23 modulus 10, then the remainder will be 3. So as you go to up to the 24, modulus 10 is 4. 25 modulus 10 is 5. 26 modulus 10 is 26. 29 modulus 10 is 9. And then 30 modulus 10 is 0. So notice how it goes back. It counts from 0 to 9 and then back to 0. It's a good way of controlling that kind of stuff. If you put you can just, well, this one should be pretty obvious, but if you do a unary operation such as put a minus sign in front of here, that makes it negative, right? You can explicitly do a positive, but that's completely pointless. No one does that. It doesn't hurt anything, but it doesn't really do much. So let's look at this plus plus and minus minus. Plus plus and minus minus, these two right here, tell me to increment by 1 or decrease by 1. Increase by 1 or decrease by 1. Increase by 1, decrease by 1. So if I do 3, if I do plus plus 3, this should output the number 4. Why can't it do that? Oh, you can only do plus plus on variables. My mistake. Let's do plus plus first num. Let's get rid of this space. I don't like it there. Compile. That actually makes sense. You can't increment a literal. Okay, whatever. Let's take the 5. I don't care about the number 9. It should output 6 because 5 was the first number we put in there. We put the number 5 here. It's stored in first num. Yeah, we stored the number 9 here, but we don't actually do anything with it. Then here it increments by 1 and then outputs it. Be careful though. If you do num plus plus or num minus minus, it will output 5, not 6 like it did last time. It would output 5. And then on the next line, it'll be 6. So if I do system.out.print line first num again without incrementing it, watch what happens. And let's do 5 again. Let's do 0 just to kind of get it out of there. And then 6. It outputs 5 and then 6. Because on this line, it says, give me the number, and then at the end of this line, increment by 1. That's why it outputs a 5 first. Then over here, it says just output what it is. Well, we incremented it at the end of this line, which was right here. So it became a 6. And then the next line says output it. Okay, well, it's a 6, so output it. The not symbol is inverts a Boolean value, which I already deleted my Boolean value, but if I said is Boolean is short equals true, and then I can just do not, that's what the exclamation says, not is short. It'll output false. Did I compile? I think I did. Compile. Okay. False. It inverted the Boolean value. We already did some simple math. Java math class examples. It's got a bunch of functions. Could be useful for some arithmetic. All right, make a new project. Here's something I recommend you guys doing. Make a new project and a new class. Don't forget to make a main method. Write a quick program that takes in someone's username using scanner.next, height, not next int, here we're using scanner, their height using scanner.next int, and prints out something like, hi Ben, you are 5.7 feet tall. Hint, you'll need to format the decimal to print only one digit after the point. You can probably skip that if you want, just have them input something, whatever it is. You can Google how to format this, but I'm changing this. I don't really need to kind of worry about that yet. So let's go ahead and do that. I'm actually just going to stay here and just leave this here. So we make a new class, whatever it is, made a main method. Make a quick program that takes in someone's height. So let's do int height. No, actually, let's do, yeah, it's going to be double height equals, oh, I need a scanner object. I forgot that. Scanner in equals new scanner system.in in.next int. I'm actually doing this out of order, but that's okay. And then string name equals in.next. Now I don't want to do next int because the string is going to accept an integer if I do next int, right? But I want to accept anything that's next. Next int, actually this wouldn't work either. Let's do this. Next double. We'll just do it that way. I'll change this here. Anyways, let's just do system.out.println, and then I would say we want to say hi space plus, we're concatenating strings here, hi, and then name. You, oh, apostrophe, you are, and then height, plus, come on, plus, feet tall. And then don't forget your semicolon there. All right, let's see if this looks pretty good. So remember that the first one's going to be, we can just memorize it, or we can actually put in some prompts. So if we want to put in some prompts, we can do system.in, oh, I'm sorry, system.out.println. Actually, let's do print. Please give me your height. How tall are you? Right? And system.out.print name. Right? It could be any characters. This colon here is perfectly fine. And then next, and then it's gonna print that out. Okay, let's compile this, see how it goes. How tall are you? 5.7. Name? Ben. Hi Ben, you are 5.7 feet tall. Ta-da! Okay, I think that's it. Like, that's actually it. Yep, slide 15 out of 15. If you have any questions, leave a comment in the video. I think that should be it. It doesn't cover everything. If you want to know more about variables, try that Geeks for Geeks link that I told you about in lesson 0. Or if you have any more questions, try looking at Stack Overflow if you have something a little bit more specific. But that should cover this for now. I will see you guys on the next lesson. Thanks very much.